Octus is a search engine, like Google but for datasets. Similar to Google, you can pose keyword-based search queries. For example, you can search for datasets on cyclist behavior by typing in the search box. Auctus then retrieves and ranks the most relevant datasets from its index. For this particular example, Auctus fetched over 30 results. We can quickly inspect them. Let's explore the highest ranked result, cyclist crashes in Australia. Its snippet on the left shows key features including its description, the names of its columns, and their data types. Before adding a dataset to its index, Auctus profiles its contents to derive metadata. Here, you can see that the profiler detected both temporal and spatial attributes. When you click on a result snippet, you can see a summary of its contents. For example, the user can inspect the spatial coverage of the dataset on a map. Users can also inspect a sample of the dataset contents, the columns with the inferred data types, and by selecting column view, they can see statistics for the columns. The goal is to provide enough details about each dataset so that the user can more quickly ascertain its relevance. If the user finds the dataset relevant, she can then download it. A novel aspect of Octus is that it supports a rich set of data discovery queries. Besides keywords, users can also explore dataset collections based on space, time, and data relationships. For example, if the user is interested in datasets about bicycle usage but only in the United States, she can type cyclist in the search box and additionally click on any location to specify a spatial constraint. Here, she can create a polygon around the US. Note that the results now only show datasets from the United States. We can also specify a time period of interest to find datasets that are more aligned with our information needs. If we want the most recent data, we can search for datasets from 2019 to 2021, and we can also specify the desired temporal resolution, for example, with timestamps on a daily basis. Octus allows data augmentation queries. Let's suppose that an expert in the New York City Department of Transportation is trying to understand bike usage in New York City. She searches for relevant datasets by typing a simple query in the search box, and after some inspection, she decides to use a dataset on bicycle trip counts on the East River bridges. She wants to use it to create a model to see if daily temperatures, represented by attribute height temp, help predict the number of bikes crossing the bridges, represented as total. Unfortunately, this dataset only covers the month of April 2020, which is not enough to understand how bicycle usage varies throughout the seasons. She then goes back to the snippet of the dataset and presses button Search Related to see if she can find more compatible data records to build a model. She sets the option Augmentation type as Union and then re-executes the search. By inspecting the resulting dataset, she sees that it contains the same kind of data, but stemming from May to October 2020. The Augment Options tab informs her that a union can be performed between her input dataset and this new dataset, listing the matched attributes. By pressing the Merge Union and Download button, Auctus automatically performs the union and downloads the augmented dataset to her machine. She then creates a simple regression model to see if daily temperatures are good enough to predict the number of bicycles crossing the bridges. As we can see, she obtains an R-squared score that is close to 0.25. This model is probably underfitting the data for lack of features, as it relies only on temperature to make predictions. Using Octus, she can search for additional features for her model. By uploading this augmented dataset, she can search, for example, for weather-related datasets that are joinable on datetime to include more features on a daily resolution. After inspecting the results, she selects the augmentation with dataset Weather Data NYC 2020, which includes information about rainfall. She then selects the attributes she wants to keep and downloads an augmented dataset. When rerunning the random regressor over this new dataset, the R-squared score increases to approximately 0.56, a significant improvement. Octus allows users to filter results by data type or source. We also provide a Python API and an HTTP API to access the search engine. For more information about Octus, check our GitLab or GitHub repositories.